This is the video for section 18-2 in accelerated geometry, where we're going to be talking about graphs of the 4 other trig functions. We're going to be talking about tangent, cotangent, secant, and cosecant graphs. So the central question for today is, what are the characteristics of the graphs of the tangent function and the reciprocal trig functions? All 4 of these graphs are very different from the sine and cosine graphs that we've been looking at that have been one consistent wave that's periodic. Now, all of these graphs are still periodic, but they're not consistent. They're not continuous. If you were to actually go around your unit circle and plot points for all the values of tangent for all of the angles on the unit circle from 0 to 2 pi, that would give you these 3 pieces right here. You'll notice tangent, remember, is equivalent to sine of x over cosine of x. So anytime that cosine is 0, tangent is going to be undefined. So you'll notice here that we have vertical asymptotes everywhere that on your unit circle cosine is 0. So that would be at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and so on and so forth, forever and ever along that x-axis, because the graph's periodic. So the domain for tangent is not all real numbers anymore. It is pi, x cannot equal pi over 2 plus pi n. So what this means is we write down the first place past 0 that we have a vertical asymptote. So that would be pi over 2. And then this tells us how far we travel before it repeats itself again with another asymptote. So we have an asymptote at pi over 2, but then we travel pi units before we have another vertical asymptote. So that's pi over 2 plus pi n, meaning that if we go any amount of pi units, as long as n is a whole integer, we'll have another vertical asymptote. The range is not restricted, because if you look at these red curves, they can go as low as they want and they can go as high as they want. So in this case, the range would be, you could write it like this, or you could say the range is all real numbers. The period is the width of one of these red curves, which if you look, it goes from negative pi over 2 to positive pi over 2, basically the width between the asymptotes. So the period is pi instead of 2 pi, which is what we have for sine and cosine. And then the amplitude, you can either say that it has none or that it's undefined, because since our range is all real numbers, these graphs don't have a height, so there is no amplitude. Then we look at the cotangent graph, and since cotangent is the reciprocal of tangent, literally all we do is we take every single y value for the tangent graph and we reflect it over the x-axis. So we took all of these red curves and we just flipped them upside down, and that gives you your cotangent graph. Now that also means that since cotangent is cosine of x over sine of x, anytime sine is 0, we're going to have a vertical asymptote. And so you'll notice we have sine is equal to 0 at pi, 2 pi, 0, negative pi, and negative 2 pi, and so on and so forth. So at every interval of pi, we have an asymptote. So the domain is x cannot equal pi n. So any whole integral value of pi, we would have an asymptote. So that would be our domain restriction. The range, though, once again, is all real numbers. The period stays the same because we have that same width between our asymptotes. And then the amplitude is undefined once again. So as far as transformations of tangent graphs go, we're really only going to have 2 that we're going to look at. We will have either a period change, which would be when we have a number in front of the x, that would result in some sort of horizontal stretch or compression. And so that period, instead of 2 pi over b, like for sine and cosine, it's pi over b. And then the asymptotes, since our normal tangent graph has asymptotes at pi over 2, any transformations with a b value in front of that x are going to be pi over 2b plus pi n over b. So just whatever that b value is. And then as far as a is concerned, A is just going to stretch those red curves and make them either steeper or flatter. And so that would be a vertical stretch or compression. So for number 1 here, it says using f of x equals tangent of x as a guide, graph g of x equals 1/2 tangent of 1/4 x. Identify the period, x-intercepts, asymptotes, domain, range, and all the transformations. And you'll notice here that I did not include a graph for that is because I want us to do this on our calculator, because I want to talk about how to graph these. So let's go to y equals, and we're first going to type in the new function, 1/2 tangent of 0.25 x, because it's 1/4 x. Now, you do need to go to your mode and check and make sure that you are in radians for what we're about to do for our window. Now, mine is, I typed the wrong number here. There we go, 0.5. Now, for your window, I want your window to go from negative pi to positive 3 pi with a scale of pi over 4. And then I want your y minimum to be negative 4, your y maximum to be positive 4, and your y scale to be 1. Once you have set all of that, so that was negative pi, 3 pi, pi over 4, negative 4, 4, 1. And if you need to pause this for a second to get your window set up, then pause it or rewind it and listen to those numbers again. Then hit graph. Now you'll notice that this has got a whole lot less of our little wavy curves than we had previously. That's because we have both a vertical compression and a horizontal stretch, and that horizontal stretch has stretched out our period. So my period now, rather than it being pi units before I repeat, my period is going to be pi divided by the coefficient in front of the x. So that becomes a period of 4 pi, which if you look at this, if my window goes from negative pi to 3 pi, that is a full length of 4 pi. Does it make sense if I took this little blue curve over here and slid it over here to the left? Would it match up with this one? So essentially, am I looking at one full curve here? Yes, I am. So that's my period. Now for x-intercepts, we want to identify the first one that we see, and then we'll talk about how often they repeat. So the first x-intercept is pretty easy to see. I see that it occurs at 0, and then it's going to repeat however long my period is, because we only have 1 0 on every little tangent curve. Now, I put 0 plus 4 pi k. You can use n if you want. You can use k. You can use any other number you want, as long as we specify that variable is an integer. So those are where my x-intercepts occurs. My asymptotes, the first asymptote I see occurs at this line right here. So remember, our increments are by pi over 4. So if you're not sure where that is, you can just count by pi over 4. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi, 6 pi, 7 pi, 8 pi over 4, or 2 pi. And we have those at the end of every single one of our waves. So that is going to repeat every 4 pi k as well. My domain then is going to be that x cannot equal wherever my asymptotes occur. So whatever you write for the asymptotes, you just go rewrite the exact same thing for domain, except you put cannot equal. Your range then will be all real numbers. That will be the case for both tangent and cotangent. And then our transformations. We had, looking back at the equation, we have a vertical compression by 1/2, and we have a horizontal stretch by the reciprocal of that coefficient in front of the x, so by 4, which is why our period went from pi to 4 pi. So cotangent works exactly the same way. The period is going to change by pi divided by whatever coefficient is in front of the x, and then the asymptotes, since they're normally at pi n, they're going to be at pi n divided by whatever that coefficient is in front of the x. So I want you to pause the video for a minute, and I want you to keep the window the same as what it was for tangent. If you have that window set, you can keep that same window for all the graphs we're going to do for all the sine, cosine, tangent, cotangent, secant, and cosecant when we get to those. So graph this and see if you can get all of this information filled out. So hopefully you got a graph that looks like this. If you weren't quite sure how to type cotangent in to graph it, you could have done y equals 0.5 times 1 divided by the tangent of 3x. That's exactly what you would have typed in your calculator, and hopefully your graph looks like this. If you kept your window exactly the same, then you should be able to find all of these things relatively easily. The period, remember, is going to be pi divided by your coefficient in front of the x, so my period is pi over 3. Now, I told you with the x-intercepts to write down the first place that you could see past 0 where you had an x-intercept. On this one, though, you might have had a hard time determining exactly where this first place is. So what I would suggest is that if you have a difficult time with that one, maybe keep moving until you can finally find an exact place, because hopefully you will, that it crosses the x-axis. So if you notice that your second x-intercept is exactly at pi over 2. So that means that my x-intercepts would be at pi over 2 plus whatever my period is times k. And it's okay to write it like that, because if I use a negative k, then that would make me go backwards by pi over 3, which would take me right back to this first x-intercept. So my answer right there is exactly correct. Your asymptotes, the first place that I see an asymptote is actually at x equals 0. So my asymptotes would be x equals 0 plus pi over 3k, which means that your domain is that exact same thing, except it says x cannot equal 0 plus pi over 3k. Your range is going to always be all real numbers for all cotangent graphs. And then your transformations are a vertical compression by 1/2 and a horizontal compression by 1/3, because we use the reciprocals for the horizontal. Okay, so moving on, let's talk about secant and cosecant now. Secant graphs, if secant is the reciprocal of cosine, do you see this blue curve here? This is the cosine curve. To get secant, literally all you do is you take every single y value and you do it as 1 over that number. So it basically just flips everything out either across the line x equals 1, or excuse me, y equals 1, or y equals -1. So you get these red curves that you basically take the blue curve and you flip it outwards. So the only points that cosine and secant have in common are at 1 and at -1. The rest of them change completely, which means that your domain is also going to change. You'll notice that we'll have asymptotes anytime that cosine would have been equal to 0. So at pi over 2, 3 pi over 2, we have these vertical asymptotes. So like I said, the first place that we have a vertical asymptote is at pi over 2. So my domain is x cannot equal pi over 2 plus pi n, because the domain of secant is pi instead of 2 pi. Now the range, instead of staying between -1 and 1, it has to stay completely outside of -1 and 1. So we write that as y is less than or equal to -1, or y is greater than or equal to +1. And you do have to write both of those for your range answer. The period is still 2 pi, and this time our amplitude is again undefined, because we can go as low as we want or as high as we want, even though we have this white space in the middle. Cosecant works pretty much the same way since it is the reciprocal of sine. We literally took every sine value and we reflected it either over the line y equals 1 or the line y equals -1. So either right here or right here. And we flipped the blue sine curve outwards to create the red parabolas that make the cosecant graph. And so any place that sine is 0, we're going to have a vertical asymptote now. The first place that that occurs is at 0, and then at pi, and then at 2 pi. So our domain is that x cannot equal any integer increment of pi, so pi n. Our range is exactly the same as it is for secant. Y is less than or equal to -1, or y is greater than or equal to +1. And our period is still 2 pi, and our amplitude is undefined. Notice that these are extremely similar, just like sine and cosine are extremely similar. Really, the only thing that's different in this whole list are the domain restrictions. So we're now going to graph some transformations of these, starting with 1/2 times the secant of 1/2 x. And you've got a graph there on your paper to plot the points, but we're going to do it on the calculator just like how we did the tangent and cotangent graphs. So I'm going to type in 0.5 times, for secant, I'm going to do 1 over the cosine of 0.5x. And then our window is still set from what we had before. So you're going to hit graph. So this is the graph, hopefully, that you end up with. So the period, since our period normally is 2 pi for secant, we would do it just like we would do the cosine graphs, and you take 2 pi divided by the coefficient in front of the x. So this period is now 4 pi, which makes sense because if this is -pi over here and this is 3 pi over here, that is a total length of 4 pi units before we see one full upward parabola and one full downward parabola. We have to see one of each of those in order to make a full period. Our asymptotes, if you find the first place where you can tell you have an asymptote, which is right here, counting by increments of pi over 4, that occurs at x equals pi. And then that's going to occur half of our period. So every 2 pi units, I'm going to have another asymptote. So you should have 2 asymptotes for every period. And then your domain is going to be the exact same thing you just wrote for asymptotes, except you're going to put a do not equal sign. Your range, since we had a vertical compression of 1/2, that means then rather than saying y is less than or equal to -1, we say y is less than or equal to -1/2. Or instead of y is greater than or equal to 1, we say y is greater than or equal to 1/2. Because if you look, here is -1/2. That's the vertex of that parabola. And this vertex is at +1/2. And then our transformations, we have a vertical compression by 1/2. And then our period stretched, so we have a horizontal stretch by 2. All right, now I want you to pause it and I want you to give number 4 a try with g of x equals 2 times cosecant of x. Okay, so hopefully this is the graph that you got, which really doesn't look very different from the original cosecant graph, except that our maximums and minimums have now changed. Rather than being at -2 or at -1 and +1, they are now at -2 and +2 because of this vertical stretch right here. But everything else in terms of our period, our asymptotes, and our domain stayed exactly the same. So your period is still 2 pi before you see a full up and a full down curve. We would get all the way over here to 2 pi before that happens, which means, and then your asymptote occurs halfway between those, So your first asymptote occurs at pi. So your asymptote would be x equals pi plus, the next one occurs after another pi units. So pi plus pi k, which makes your domain x cannot equal pi plus pi k. Your range, because of the vertical stretch, becomes y is less than or equal to -2, or y is greater than or equal to +2. And then your only transformation is a vertical stretch by 2.